This is Amir Jafari, your host today. In this series of lectures, we are going to talk about a very interesting problem in astrophysics and plasma physics, magnetic reconnection. It's a ubiquitous process. It occurs in laboratory plasmas, for example, fusion devices, and also in astrophysics, almost everywhere in astrophysics, astrophysical environments, like galaxies, accretion disks, the solar corona, stars, this is a process that you can observe. And so both these communities, plasma physics and astrophysics communities, are involved in the research on magnetic reconnection. So it's a vast field of active research. We're not going to cover all aspects of magnetic reconnection and all questions and problems related to magnetic reconnection, obviously, in a couple of lectures, short lectures on reconnection. But we're going to give we're going to try to provide a big picture, and we'll talk about, open problems and also misconceptions, misunderstandings, the confusion that there is about, for example, turbulent magnetic reconnection, the role of different instabilities, and turbulence, in reconnection theory. So we're going to try to give, provide a big picture with some, mathematical detail, but we're not going to go into, much details about different, models or different aspects of the problem. To begin with, in this short introduction, I'm not going to talk about technical aspects, but I'll give you a definition. Although there is no unique definition, like many other phenomena in physics, for magnetic reconnection, but you can define it as follows. Magnetic reconnection is the sudden change, a rapid change in magnetic field pattern in a magnetized plasma, okay, which leads to the acceleration of plasma, the acceleration of the fluid where magnetic field reconnects. So you have a pattern. You can think about magnetic pattern in terms of field lines, although I'm going to argue in the future lectures that this is not the best way to think about magnetic reconnection, because there are problems with field lines defined in a plasma. But you can think of a magnetic reconnection like as snapshots, as you take from, the pattern of magnetic field in terms of field lines. And then all of a sudden, and this pattern evolves in time, right? Because you have magnetic field has its own dynamic. It's interacting with the plasma velocity. Sometimes in some regions of plasma, you have this sudden change in this magnetic pattern, which leads to the acceleration of plasma, acceleration of particles, ions, electrons, etc. So magnetic field kind of relaxes to a lower energy, and the magnetic energy is released in terms of the kinetic energy and heat of the inside plasma, the plasma parcels of plasma or fluid parcels. So this is what can be said at this level. But in the first lecture, I'm going to be, as always is, but my strategy is always giving you a very simple picture in the first lecture without delving into much technical details. We're going to talk about simple models of magnetic reconnection, for example, sweep marker models. And then we'll argue that this is not compatible with observations and experiments, so something is wrong with this model. So there have been many suggestions and many processes actually suggested as remedies why sweep marker model, this simple model, doesn't work and is not compatible with experiments and observations. But among these processes affecting magnetic field reconnection, one thing stands out, which is turbulence. And I'll argue, and we'll see in some details, mathematical details, that in fact turbulence is the major player. It's the major process that affects magnetic reconnection and its speed, its mechanism overall. And you can ignore basically other processes which come from small-scale plasma physics, for example, different instabilities like the tearing modes and the Hall effect, the Bohm diffusion, the geometry of the reconnection zone, etc. So although these processes are important at some level, especially for plasma physicists, but it turns out that especially in astrophysics, these processes are kind of subdominant. They don't play a major role, and the only thing that you have to worry about is turbulence. So this is why we're going to focus on turbulent magnetic reconnection, which is what happens in astrophysics. Turbulent magnetic field reconnection occurring in a turbulent medium, turbulent plasma. And if you don't know about theory of turbulence, for example, magnetohydrodynamic turbulence or hydrodynamic turbulence, uh, it's okay because I'm going to try to cover the concepts which we borrow from those fields, and I'm going to explain them. So there is no need for any background from those theories. So if you have no experience from those areas, no worries. We'll cover the notions and concepts that we need to understand before studying turbulent reconnection. So I guess that's it for this short introduction. I'll see you in the first lecture where we're going to talk about the simplest model of magnetic reconnection, and then we'll see how and why we need turbulence to study real magnetic reconnection. And in the second lecture, we're going to start our study of turbulent magnetic reconnection.